Welcome to all of you, and good morning also from my side. As Ronald said, this is a huge step for us now to take with the publication of our proposal today, and this is actually it. So everyone will be able to see and read through it. And this is just the summary, just to tell you. In the next 20-25 minutes, Richard and I will give you a short overview of the proposal. And I will start with presenting some background on PFAS and how in our proposal we are going to justify that this restriction on an EU-wide basis is needed. And Richard will then dig a bit more into the proposal as such and also shine a light on the implications it will have on companies and on society. The proposal was prepared in a joint effort by 5 European countries, with the Netherlands and Germany formally taking the lead, but strongly supported by our colleagues from Denmark, Sweden, and Norway. So over the last 3 years, we have been working together very closely, collecting a lot of information, assessing a lot of information, and drafting this proposal, which is also called an Annex 15 restriction proposal in the context of the REACH regulation. And before now moving on into more details, I also would like to mention that this proposal is also often referred to as the universal restriction proposal. You might have already come across this term. And universal, the adjective universal in this context refers on the one hand to the broadness of the proposal, both in terms of the number of substances that are covered, but also the number of uses that will be affected. On the other hand, it's also a good way to distinguish this proposal from previous, more specific restriction proposals that have been submitted for certain subgroups of PFAS. And just to give you an example, there's a proposal for PFAS in firefighting foams that has been submitted last year by the European Chemicals Agency and which is currently still in the scientific assessment phase, but shortly moving on to the political decision-making phase. So to start with, and Ronald already mentioned this, PFAS are forever chemicals. And this is because of their very high persistence. So PFAS consists of a carbon-fluorine structure, with the carbon-fluorine bond being one of the strongest bonds in organic chemistry. So we can say that all PFAS are either persistent themselves or they degrade into smaller persistent PFAS. And because of their persistence, they will just remain in the environment for very long times, up to decades or even centuries. And if exposure of the environment continues, concentrations will just continue to build up and they will always increase. In addition to this very high persistence, PFAS also have other problematic properties. And in combination with this persistence, this is really raising high concerns. So PFAS can bioaccumulate, they can enrich in animals and in plants. Some of them are mobile, so they distribute very easily via the water phase and can be found all over the globe. They also have a long-range transport potential, so we can, as I said, find them everywhere. And we also know of some PFAS that they have adverse effects, can have adverse effects. So we know for some PFAS that they are carcinogens. Some PFAS can damage or can put damage to the unborn child or can even have effects on some organs, as the liver, for example. So concerns are growing about the whole group of PFAS, not only those on which we have the good knowledge. And if the levels of PFAS continue to increase in the environment, they will build up just until the safe exposure levels are exceeded, and then the adverse effects on humans and on environment will just be inevitable. So I already mentioned in the beginning that this restriction proposal is also referred to as the universal restriction proposal, and that this is due to its broadness. And we can say that this proposal is actually the broadest restriction proposal that has ever been prepared and submitted. The definition of PFAS is based on its chemicals, on their chemical structures, so it's not really possible to provide an exact number. PFAS have already been manufactured and used since the 1950s. And we estimate that around 230,000 tons of PFAS are placed on the market, newly placed on the market every year, not accounting the PFAS that are already there in technical stock and in products. So you can imagine that this amounts up to far more. And a rough estimate, looking at different lists of PFAS that are available around the world for different purposes, we can say that there are at least 10,000 PFAS that will be covered by our proposal. So what is the reason? Why are the number of PFAS consistently growing, and why are PFAS used so much all over the world and all over the sectors? From a technical point of view, PFAS have a combination of very useful properties. They are water, oil, and dirt repellent, which is quite handy when it comes to impregnation, for example, of textiles. They are also very durable under extreme conditions, be it high pressure or temperatures. They are inert towards radiation and also towards other chemicals. And they also have electrical and thermal insulating properties. So keeping this in mind, it's not really surprising that PFAS are used in so many different sectors. And this is what I'm showing you on the next slide. These are the sectors, the overarching sectors where PFAS are used. And PFAS are used in many applications in industrial processes and also by a lot of professional users. And PFAS are also present in everyday consumer products, such as the non-stick cookware, the rainwear, and even in cosmetics. As I said, these are just the overarching sectors. So if we dig deeper into these categories or into these sectors, there are much more individual or single uses covered by this. And just to provide you a few examples, if we're looking at the textile sector, textiles is not only the textiles as such, it also covers furniture or upholstery, leather, apparel, and carpets. So there's a lot more covered here. And also, if we just look at this part, then we can further distinguish into home textiles, sport textiles, and professional apparel, and also technical textiles, for example, for medical purposes. And similarly, if we look into the applications of fluorinated gases, there are also many different or various uses covered below this category. They are used as refrigerants, for air conditioning and for heat pumps, but also as fire suppressants, as solvents, and as foam blowing agents. So the main message here is PFAS are used in many sectors, and within these sectors, there are many diverse applications of PFAS. And just as a final remark on this slide, and you see this last bullet point, other uses, just to mention that from the information that we have collected from stakeholders, we are quite confident that we have covered the majority of uses in our dossier, but of course there might still be other uses that might come up later in the process. And Richard will explain how this can happen. So if we're looking now into the life cycle of PFAS, starting on the top left with the PFAS production, for example, the production of fluoropolymers, PTFE as a prominent example. These PFAS are then used to produce products, and with products I mean here both can be articles like the frying pan, but also mixtures like, for example, cleaning agents. Then moving on, in the next stage, the products are used, and at the end of their use, they are thrown away, or they enter the recycling phase, and they are going into the waste management. And in all of these life cycle stages, emissions into the environment occur from the different processes that PFAS are used in, or products that PFAS are used in. And an estimate that we did in the context of our restriction proposal is that there are about 75,000 tons of emissions just occurring from the right-hand side of this graph, of this life cycle, so just from production and use, not taking into account the waste phase. And from the waste phase, we still expect a significant share of emissions to occur. And we also try to estimate this in our dossier. We just think that this estimation is too uncertain to consider it in the impact assessment, but it has been taken into account. And just to give you a dimension, or just to explain this dimension of 75,000 tons, how much is it? If you think of middle-class cars, 75,000 tons are about 50,000 middle-class cars. And if you line them up just one after each other, it will form a traffic jam from here to Cologne, so 220 kilometers. And to put this even more into perspective, if emissions continue, if we don't act now, over the next 30 years, these emissions would sum up to 4.4 million tons of PFAS in the environment. So I already explained how PFAS get into the environment, and this is also demonstrated by monitoring studies. So we have supportive evidence that PFAS are already in the environment. PFAS are found in surface and groundwater all over the world, in animals and in plants. And also humans are exposed to PFAS, mainly via consumer products, but also, of course, via the environment. And there's also uptake from food and from drinking water. And this is also supported by human biomonitoring studies with the highest exposure levels in populations close to the emission sources. For the environment, on the contrary, we do not find PFAS only close to the sources of emissions, but as I said, they have potential for long-range transport, so we also find them in remote areas far away from any emission source. Okay, to sum up this first part of the presentation, PFAS are used in high tonnages, and PFAS can have adverse effects on the environment and on human health if exposure continues and safe exposure levels are exceeded. Emissions occur in all life cycle stages, and monitoring data already demonstrate their omnipresence in the environment and also in humans. PFAS are highly persistent, they are forever chemicals, and if we don't take action now, there will be adverse effects, as I already said. PFAS are also very difficult to remove once released into the environment. Even by technical means, it's almost impossible, and if it is at all technically feasible, it's very costly. So there is an uncontrolled risk, in our view, from the use of PFAS in the European Union, which needs to be addressed by a regulatory measure. And this is the restriction we are now putting forward, the proposal. And we think to address this problem on a large scale, it's way more efficient to do this in a group approach, so to address all PFAS now in one go compared to previous restriction proposals where they were more addressed one by one. And this will also help to avoid regrettable substitution, meaning replacement of one hazardous PFAS by just another one. And with this, I hand over to you, Richard.
Yeah, thanks, Frauke, for this very nice introduction. I will now take over and do my part of this co-presentation. It's a joint effort that you see, so it's very important. And I will kick off with taking you back a little bit and telling you about the process, so the process steps we took to arrive here where we are today. Actually, we kicked off in January 2020 with this group of people that had a first meeting. But before that, even in 2019, I think you all could remember that the European Commission drafted, the Council asked the Commission to develop a so-called PFAS action plan. And later on in 2020, this was taken up as part of the European Green Deal in the Chemical Strategy for Sustainability. And I think this is formed a very important basis for the work we see presented today in this dossier and the additional 1,800 pages of annexes that accompanied this summary. So that was actually the basis of our work. The member states then later on in 2020 committed to take up the work under the REACH regulation and to work to build actually a dossier, because proposing such a big restriction you can only do in a proper way by using the institutions, the formats, the guidances that are there within the REACH context and build a dossier based on appropriate information. And that's what we've done. So we reached out to stakeholders, as you can see. Oh, sorry, I forgot to skip. Sorry. The timeline, sorry. And the timeline here shows you that we reached out a lot in this initial phase. So we discussed with stakeholders, organized meetings and calls for evidence, etc. We got this information to build our dossier. That ran actually for this whole period until we started really drafting in October 2021, and we knew we had to submit the dossier by January this year, and we succeeded. So by the 13th of January this year, we actually submitted the dossier at the European Chemicals Agency, who takes it forward now. And we're here now today, so the 7th of February, we have the publication of the proposal. So we will take it forward from here, and I will take you now a little bit more insight into the restriction proposal. So the dossier I talked about contains actually two parts, two main parts. A risk assessment, which is the underpinning of why we need to take action, like Frauke explained. So there's an EU-wide risk we identified and the need to take action. So that's underpinned by the risk assessment. And on the other hand, we have the impact assessment. And that is the part of the dossier where we assess the impacts. So on the one hand side, the benefits that are caused by this restriction, so the reduction of the emissions, which we consider a proxy for the risk. So you will later on see that this restriction is estimated to have a huge effect on the emissions of PFAS in a good sense. And on the other hand, we also estimate the costs, for instance, for industry, that will be incurred upon them because they will have to transition from PFAS to PFAS-free. That's the main thing, actually, what we do there. And very importantly, also in this impact assessment is the analysis of alternatives. So we have gathered as much as information as possible on the possibilities of these factors you've just seen on the screen, and these uses and their sub-uses to transition to alternatives. For some, we have very good information. We know already that transitioning is feasible. For others, it's difficult, or we just don't know yet. So there are also still data gaps, and that's why we see later that we still have have to reach out again in the next steps to take. So the proposed restriction is actually two options, and I have them on the screen. We have either a full ban, which takes immediate effect after a transitional period of 18 months, which is kind of standard within REACH. It's kind of the selling out of stocks, 18 months is a generic transition period, which is considered reasonable. And the proposed restriction option, which is option 2, it's a ban with use-specific derogations, which we underpin based on information we got from the industry and from other stakeholders. So we propose this restriction option 2 based on primarily this analysis of alternatives and the possibilities or impossibilities to transition on a certain time frame, within a certain time frame, and other socioeconomic considerations. And this is built up in the impact assessment. So, and I think that is important to remember that the analysis of alternatives play a hugely important role in the underpinning of these transitioning periods. Both options are fully analyzed in the dossier, and that's why I have them both on the screen. And if you read the dossier, you can see that we do a risk assessment and an impact assessment for both options. And also we make a comparative analysis. On the restriction conditions, those of you that are familiar with the restrictions know that restriction can cover all these aspects. And it's what we propose is a ban on manufacture of PFAS. So it means, for instance, PFAS polymers, PFAS monomers. So all PFAS within the domain as presented by Frauke. Also the placing on the market and the use. And this is for PFAS substances as such, but also the PFAS substances contained as constituents in other substances and in mixtures. For instance, lubricant spray containing PTFE, for instance, which is an example of a mixture. But also in articles, for instance, PFAS contained in an electronic device. It's all covered. And there's a lot of nuance, of course, between these uses, how we approach the transitioning to alternatives and the transitional phases. Of course, we have a concentration limit. Every restriction needs a concentration limit. I will not explain the details on that, but we have both a specific concentration limit, focusing on analysis of specific PFAS, but also a generic one, in which we look at total fluorine content. This is really to also facilitate enforcement of this restriction. It's very important. Then there's this generic transition period, which I mentioned, 18 months, that applies after entry into force. And last but not least, we have use-specific, between brackets, time-limited derogations. We even have some time-unlimited derogations, also worthwhile to mention. You can read those in the dossier, very specific ones, very exceptional cases. But this is the main, summary actually of the content of the proposal. Then we look at I would say, call it actually the default of this restriction is a ban after 18 months. And on this slide are just a few examples, very more tangible examples. I think the non-stick cookingware, so the frying pan, also the food packaging, pizza box, for instance, ski wax, cosmetics, and cleaning agents. These are also tangible examples of consumer applications of PFAS, but there are also, and many of these consumer applications, we propose a ban after 18 months. Because we know, for instance, for food packaging, alternatives do work and are on the market, etc. And also in other regions of the world, this has been applied, as you may be familiar with. So that's why we propose a ban quite soon. This also applies to some professional users and some even industrial users for which we apply this ban. Also importantly, and that links back to what Frauke earlier mentioned, that we have a picture of all users, but we're not 100% sure we cover all users. There may be future users, also plans to use PFAS in future for other applications. This is also covered by the proposal. These will be banned. So when this restriction enters into force, PFAS cannot be used any longer. So these are also covering those uses. About the next slide is about, it's an important slide because it tells you about a kind of practical solution we found because of the huge number of sectors and uses covers. We considered it would be appropriate to work with two timeframes for transitional periods. And we have a time frame for transition of 5 years for those cases where we have information on alternatives that are almost there, they are under development, but there is still time needed to further develop them, or they are not yet available at sufficient quantities before entry into force of the restriction. So then we propose a 5-year derogation time frame. And an example is the use of food contact materials in industrial settings. So for instance, the machinery that we use in the food industry to make food, to produce food. The other time frame is 12 years. Yeah, you can consider that a long time frame. It is much longer than 5 years, but this is really for those cases where we have no alternatives yet available. The identification and development of these alternatives will take time, and we have evidence supporting this. And for one of the examples is that, for instance, there could be certification schemes, legal obligations, patenting, etc., leading to long time frames to develop these alternatives to be acceptable. One example is implantable medical devices. In our proposal, we now propose a 12 years transition period for those. For instance, it could be pacemakers or valves you use for the heart, for instance. So these are just a few examples. Now we'll go on with another example. I think it's nice to show in 2 slides how the restriction works. This is for textiles. You've heard from Frauke, textile use is very broad. It's not only clothing, but it's also furniture, carpets, technical textiles, personal protective equipment, a lot. So it's a lot covered there. The main functionality, the PFASs are used for impregnation. So textiles are impregnated with PFAS to make the textiles repellent of dirt, water, oil, etc., etc. So that functionality is sought, and what we see is we looked at the tonnage, the information we received, and it's a tonnage volume in 2020, which is the basis starting year. We estimated at 92,000 tons per year. The market volume, the use volume of that's just to give you an indication. And we also estimated the emissions during the service life. This does not yet include the waste emissions. For instance, when an article, textile, for instance, enters the waste stage, and also emissions could occur. So this is just the emissions during service life of these articles and the manufacture of these articles, 23,000 tons per year. This will add up during the so-called assessment period of 30 years to a total of 1.4 million tons of emissions. When we apply the ban, which is a full ban after the transition period of 18 months, this will go down by 95% to 66,000 tons in total over the assessment period. So this is just an example. In this slide, we show you actually the baseline of prediction of use and emission of PFAS in textiles. So the orange, it's kind of orange line shows us here I can't point it. In 2020, you have the 92,000 tons per year, and that will gradually increase, and that is based on the expected growth volumes within this broad sector of use. We expect in a 30 years period of time it to double. And of course, you see also the darker line that the purple line that the emissions will gradually increase together with that. When we apply the restriction, these lines will drop drastically to zero. So, and that is why we have this huge emission reduction and efficiency of the restriction to reduce those emissions. So now, again, a process slide, and this is also an important one because it tells you about the next steps. And I think it's important for us to show this because we're now closing actually stage 1, phase 1 of the dossier. He's submitted the dossier, and it's now in the hands of the European Chemicals Agency. and they take it forward to phase 2. Phase 2 is the phase of the scientific opinion development. We have provided a scientific basis, but it still has to be assessed by 2 committees. They form a group of independent scientific experts, and they will have to look at the dossier. That's the process within REACH. That's a normal process. Scientific scrutiny is being provided there, and it's very important that it takes place in a proper way. This process in total takes about a year. So, and we kick off now. We're here now at the beginning on far left side. If everything goes well and the dossier is accepted, we call that conformity. So that means it consists all the elements that are needed for a proper dossier. Then we have on the 22nd of March, ECHA will start a so-called public consultation, or they call it a consultation on the Annex 15 dossier. So that means then everybody will again have the opportunity to provide information to us, because we will still be involved in the process, but also to the scientific committees that are writing their opinion on our proposal and the content of the dossier. So 6 months period of consultation, and after that finalization will be by 22nd of September. And on the 5th of April, ECHA will have a big online information session involving us as well. And this will go deeper into the content. It's also for the industry, for the stakeholders, to get more details about the proposal, to learn where probably there are still data gaps, needs for further information, etc., etc. So that is very important to remember that date. I think it's in the agenda of many industry and stakeholders, that date already, because it's already published on the ECHA website. Then somewhere in 2024, we expect to have the opinions, and the opinions together with our dossier as a background document will be sent by ECHA to the Commission. Commission then will take it forward to decision making in the REACH committee, which will happen somewhere in 2025, and then it will enter into force somewhere 2026 or 2027. So that's the predicted timeline. Then this is my final slide, so I don't keep you much longer, but just to wrap up, final slide, I think. I come back to the final slide of Frauke on a few points. I think it's important. Take-home messages for you. PFAS are highly persistent and hazardous chemicals. That's why we're here today. We also saw, because of this persistent PFAS entering the environment, are there to stay. So they stay there. We can't easily remove them. It's very costly or even totally infeasible to do that. And we also see progressive buildup of concentrations of PFAS in the environment, in organisms, and also in humans. So that's why, if the releases are not minimized, we say that adverse effects are in the end inevitable. So concentration limits that are today considered safe will be breached, and this will cause effects. So there's a need for a group restriction to ban the use of PFAS, the marketing, and also the manufacture. All PFAS, EU-wide, because PFAS are mobile, as Frauke has also shown, and cross the borders. And there's also one internal market in the EU, so we can't take national measures on this big group. We should do it on an EU-wide basis. And also to prevent regrettable substitution of one PFAS by the other. This should be done as a group. And like I also explained, it's in line with the EU Green Deal, in which the Commission also promised to take actions on PFAS as part of the PFAS action plan. The ban will take effect after 18 months, and we will have, which we consider as a reasonable time frame, and we will have reasonable time frames for switching to alternatives. There's effort needed still for industry, of course, to switch to alternatives. And the environment will gain a lot, because the efficacy of the restriction will be around 95%. So that is the emission reduction, which we consider a proxy for the risk reduction of this restriction. If no action is taken, we have concluded that the societal cost of no action will exceed the cost associated with this restriction proposal. And finally, last but not least, I think we submitted a very good dossier, but it's not perfect yet. It can even be improved, and that's why we reach out to stakeholders to provide even further information during the next consultation phase, which is facilitated by the European Chemicals Agency. Thank you.